on this process?
No, no. This is when you got plates, or it could be the pattern could have been sprayed with that rather than the liquid powder. But the mold has to have the powder. This is a liquid powder, and it's like a polish.
A liquid powder.
Yeah, that's a liquid powder, and it was made out of kerosene and paraffin.
And explain.
Well, if you wanted to clean that pattern or prepare it, the mold is fill them until when they run out, to go fill them again. The material was stored in a common stock room. But then you would clean this all up, blow it off, and get rid of everything. And if you had a spot like we had, the little spot that bothered,
right,
we'd run it to the pattern shop. And hey,
chances are there's a little burr.
There's a burr on there. A draft. It needs draft. It needs some kind of repair. So we get it repaired. And then you come down and you put compressed air. You can't do it with this because you only got two hands, and it takes two to run that. But you put compressed air in and you just spray it.
Spray it right on.
And take a rag, either rub it off, let it set or anything. But the more you spray the metal patterns, they're porous, and this material works into it. And it like a frying pan that's been prepared with the fat. It aged and it lasts a long time.
So did that kind of parting, was that first? I mean, did that come before that?
Oh no, way after.
Way after.
That's one of your first, and probably the first thing they used was dry sand with no water. No trouble with that. If you take dry sand and put it in too long before you open the mold, it will absorb sand from the mold. But they probably used dry sand as one of your first patterns.
Where did I used to see them put dry sand? Was that around the mold to seal it? Remember?
That's to get vented.
Huh?
That's to vent it.
Oh, it's to vent it. I forgot what it was.
That's to vent it. If they were going to seal it, they would use green sand.
Yeah.
They would use green sand, and we also used to buy a strip of, I don't know what was in, it was asbestos or something in them strips, and they were different sizes, just cord. And if you had a mold that consistently leaked out on you, it'd give you a problem, you had trouble sealing it, you would lay that strip of that around the given area, and that would seal it off so the metal didn't come out. Then big molds that we were talking about there, 30-footers that weigh 5,000 pounds, half of them are in the cope, so it takes a lot of pressure to push the metal up into the top of that. And I don't know if you ever had one that didn't have some run out, and you had to stop that. Well, this stuff I'm talking about helps. But what you usually do would have a man on each side of the mold with a water hose. And the minute the thing started dripping, put the water to it, which is the most dangerous thing in the world, because you get iron on water and you blow the roof off in the foundry. But that's what you did, was cool it with the water.
Now, Mitch, tell them about this.
That's my horror tale. That's protective. I don't know, want to come over there?
Sure.
That's protective gear for the men that are doing, and I was hoping you had a hand ladle saved, but you didn't have. But that's a pair of shafts, like cowboys wear, and you pull them on with this, and you get the leather foot. This one's curled, but the leather has got a strap on it, which is under your foot. And this lays out over the laces, so when you're pouring, if you spill on it, it runs off and not in the shoe.
Now tell them about the stripe.
But the thing, they're dirty. The founder's so dirty, you got no place to, this is as clean a pair as I ever see, you got no place to put them that they weren't so filthy. When the molder put them on, but they didn't like them anyway. One wasn't bad. I think there's one here that's been tore apart, but if they used any, they had little ones that snapped on, like a catcher's shin guard. They had that type. But the secret she's talking about, these were forced on the molders, the union, and they rebelled of wearing them. And they told us one day, when we started work in the morning, that they would not wear them. They'd walk out before they would put them on. So we dared them, fired up the cupola, and they got it ready. Now, when the cupola's ready, you got to pour iron. That's not a coffee pot. It sits there and stews all day. The only way you can heat iron is melt more iron. It's never any hotter than when it's melted. It doesn't get hotter The new metal does. Get up to 2,700 degrees. If you've got metal that's 2,400 degrees in the bottom of the cubicle hole and you start melting, it's 2,700 degrees, and new metal gets hotter. But the stuff down the bottom don't mix and it never gets any hotter. You draw it out and replace it. Well, anyway, come 10 o'clock, because they started at 6:30, and so they'd worked 3 hours or whatever, and lots and lots of iron. And we got the cubicle ready, and we went to them, and nobody had them on. Said, hey, let's get the things on, and they walked out. And there was one old foreman, Austin Veer, and we had a minister, Merle Ladd, was a molder on the main bay, and he stayed. And me, I believe, and I'm not sure if Eddie Stewart stayed or not, but it was either 3 or 4 of us that stayed. And I was foreman then. My general foreman. And we had to pour, and in the morning, this is all hand pouring, none of the big stuff already where you use the big pouring devices. So that stuff was coming out, you melt about 3 tons an hour, and that's the rate that was coming out. And we had to pour that all day long with the 3 of us. Poor old Austin Beer was a man ready to retire. And I was
So how was it resolved? I mean...
Oh, we brought them back in, and they won. We didn't make them wear them. We didn't make them wear them. They won.
They talked about getting some down in between.
Oh, yeah, that sounds
and they are dangerous. And yet there's a couple of applications they are. A lot of the molds, when these guys were pouring with a hand ladle, and you had about 110 pounds of iron in there plus the ladle, so you're talking 150 pounds, they're lugging in one hand. It's the hand is right down, one hand is down there and there's a handle up on the other end. And this one's only to tip it or support it, but you're lugging it and there's a shield, metal shield next to your hand. And some of them molds are close as high as that. Well, you've got 150 pounds in this hand, and 100 pounds of it is iron, and you stand close to that, and you don't stand out here, and you've got that under there, and you're pouring, you can't see your feet. And you get a run out of the mold, and down comes the iron into a shoe. So there's places where these things work good way in Myrtle Lake, but that's the secret or the story on the leggings.
Well, how about the time that Leo was wearing his safety glasses? You remember that?
Without the glasses?
Well, they had to wear safety glasses when they were pouring. So here's the guy pouring away. He had an itch in his eye, so he reaches right through and was scratching his eye with no lenses in it.
Believe it or not, you had some of them guys that were stubborn enough. I won't say they were smart enough or whatever, but they were stubborn enough not to wear safety glasses. They didn't want to wear safety glasses, and you can't see them things coming in your eyes. I mean, and this Leo, he was wearing his glasses with no lenses. And
he gets caught.
and the unfortunate, I don't know how many accidents the glasses prevented, a lot of them, but the only eye injury I ever see was caused by the glasses.
Really?
The guy turned, he was pouring a mold and wood flash, and they have, what do you call the dishes? Bars. You know, with nails on the bottom, it's to support the sand from falling out. And you use them time after time in water and sand, and they rust. Well, any iron hit them rusty nails, and out it comes. And the little guy from Hardwick, he hit it, and he knew it was going to happen, and he turned, and the iron came and hit the backside of the glass and into his eye. And that's the only man I ever see that got burned in the eye from
Who was that?
Eddie Phelps.
Oh, Eddie? Yeah.
Yep. And then the worst burn, I think I told you, with Bob Delaney, which was one of these high jobs, and not this high, but this high. And the molds, he actually had his toe in under it, and he had a pair of shoes, well, something like Phil's with a cap, but the cap was unsewed. And had to run out, and the iron run on top of his shoe, and it run right down through his toes and under his foot. And that man, I was working on that machine, had the 14 men. I just started work there. And he sat down and he yanked that shoe off without untying it, leather laces. And he was a small man, but he ripped that shoe apart and took it off, and it had an iron insole in the shoe. No, that's the worst burn I see. I've seen some pretty good burns. You get pouring when you're holding that ladle in your hand. You don't squeeze it. You hold it, and the iron's always spattering, and little gobs of iron as big as peas land in your hand between the ladle and your hand, and you don't stop pouring. You stop pouring, you lost the mold, and you don't want to lose the mold, so you keep on pouring. When you get down, you get up, and the thing would be burned in half the depth of it, and you dig the thing out. It really, you got hardened to it. Your hands were callous, and the stuff didn't bother you. Well, I mean,
Yep.
we missed one tool. This is like the ram that I was using to ram the mold, but this is for a different type of molding. It's for what they call floor molding, which bigger molds, bigger castings. And it had the longer handle, it had the peen on the end and the flat face on the bottom, but it was so the molder didn't have to bend over to ram. He could ram standing up, just easier on the back. So it's actually the same tools as the short ones, and the same function. So that takes care of the tools.
Okay, Phil, now,
Well, if you had a casting that was say 2 inches thick, and you wanted a cord hole in it that was, I would say, half an inch wide and an inch the other way, that's a pretty difficult thing to make that hole in the pattern. So you'd get it pretty close to what you wanted. Then you'd take this thing here and you'd heat it red hot, and all you basically would do was drop that down in a hole that you'd made before, and you'd get the draft in there, which is what you needed to, or the draft is, or the taper on this, so you could get the sand to come out of the mold. And it was tapered this way, and every pattern that you have has got a taper on it, so it's always smaller on the drag side than it is on the coat. And if you don't, you just can't get them out of the mold. But that's just another, like say roughly a 7/8 inch diameter hole that you'd be doing the same thing. You'd drill a hole about 7/8, and then you'd just simply burn down in there, and then you'd get the draft all in there, and they'd be nice and smooth. All you'd have to do would be to use a little sandpaper.
now what do we call this tray?
Pivot tray.
Pivot tray.
Yeah, it was just a box to lug pivots. Years ago, a lot of the molds, levers and stuff, had the pivots cast right into them. And so this is the thing, they lugged the pivots around, and there were different styles of them, but there were hundreds and hundreds and hundreds of them. But they use them for toolboxes, they use them for everything. They were easy to grab.
But those levers, when those patterns were made, were probably within 15 thousandths of being right on.
Huh.
And they had to be level, and they had to be square with each other, and the dimension lengthwise had to be right on. And boy, it was amazing how close that they would cast those things.
Phil, how many people in the pattern shop do you remember at the height of your being there?
Probably the most I ever saw in a wood pattern was about 15, I guess, somewhere in that 12 or 15.
There was 12, I think, in there, when 52 when I went in there.
Well, like I say, 12 or 15, and then they had about...
you had your metal pattern shop.
about 4 over in the metal pattern shop.
Yeah.
And, of course, basically what you did, we made a wooden pattern. Then I went to the foundry. They made the casting. Then I went to the metal pattern shop, and it was all polished up and finished and whatever they had to do to get it so they could use them down in the foundry. And some of those things were a work of art, weren't they, Midge? One they had on that big slinger, boy, those things you can't believe. And that stuff took a pounding, and those were all cast iron.
And they were in a machine that was called, or Pridmore made them, International Molding. And these patterns were all set in lead or babbitt.
Yeah.
Because they stripped the pattern down out of the mold.
If you had
So it was easier to make, which not making sense to you. But them patterns were all set in babbitt.
basically, if you had this setting up here above to make the mold, they had a lever over here, and that would drop this thing, and then you'd have nothing
Nothing to pick up.
to pick up.
The machine
It was the machine did all the work.
Whoa.
But I mean, that's pretty simplified for what it was.
And that's where that liquid parting was on that type of pattern. There was alcohol lamps underneath the patterns to keep them warm, so that the cold sand, when it was cold, or even the hot sand.
Yeah.
But the pattern was kept dry, so no moisture in the pattern with the alcohol lamps.
They used to spray them pretty frequently.
Oh, yeah, and yeah.
Were these things or something like this used to number
Oh,
patterns?
sure. Sure, you just take them and lay them down and whack them with a hammer, and you'd have this impression right into your wood.
Most of them, when they used that type of letter, it was only to identify the lever. It wasn't cast into the nameplate. The nameplates were a work of art.
See,
And this was just for identification, so it didn't rub off. You mark it with chalk and make a mold, and you forget to mark it again. You take it out in that big building and dump the thing off, and they're so similar, now you're trying to find one. So that's one of the things they used just to identify them.
Now, this Fairbanks Morse, multiples 7.882, and then that was the number of the particular lever. Those were all cast onto each one of these levers had those cast onto it.
They were raised.
And they were raised letters. And it would be just like, well, basically like having this scale.
Well, they were big as that. Yeah.
Oh, well, most of them were bigger.
Yep.
Is that right?
But, yeah.
And they were made in cores.
Huh? Yeah.
They were made in cores.
They were all core.
There would be a core print on here, and the nameplate would be made in the core room. And you brought it over and set it in the core print. And then
You'd have a core print that would come out like that and then down tapered like that. So they could get the pattern out, and then they just simply set that core in there, and then they'd take a couple of nails and nail it in place so they couldn't fall into the mold when they poured it. And then when you poured it, you get the impression of this right here in the cast onto the lever, because it was on the core.
Was this number stamped somewhere into it?
No, that's just the number of the scale. I mean, that doesn't mean...
There would be a number somewhere.
Well, it's 34,200. That was 200 ton, and this 34. I don't know. That was just a.
There's going to be a symbol to that thing somewhere.
Well, right here, SX12.
Oh, okay, there you are. That's the number.
That's the number of the cast.
That's the number that's on it. This is just.
This is the particular scale. It's a 200 ton railroad track.
See, it tells you where it goes. Okay. But that's the number of that particular lever, and it would be on it.
Yeah, but you see this lever here, like I told you, Jack. See this right along here? Now, there's none up here, like on the other one.
Right.
So you don't have that plane. So this one here, you just basically would put this right here on the bottom board, ram it up, then you'd flip it over, and then you could draw, you made your coat. You could pull this all out in one shot. But you had a core here to make this hole through here. And
it would be standing up just like this. The mold board would be right down on this bottom.
Yeah.
And sand it all be here, and then when you roll it over like we did and start the second half, that whole big lever was made so it would come up out.
30 feet long.
It would come right up.
But you see the flange out here? Just on one side. Now, the one you had over there, you had another one that came out here. That's why you had to make that one that way.
You can't pull. It's got to go both ways.
It's got to go both ways.
On those patterns down there, there's some blocks that are painted black. Like that.
Core prints.
Core prints. Either black or red or yellow.
Yeah, they're like color coded.
Yeah, it's going in like a hole. You got to cast that hole in there. And that's what them core prints do. There's a print out here that holds it, but then there'd be a box or a shape of this on that would stick in when it was set down in there. This side over here would be tight against the core print, and this side right here would be tight against the sand. But you'd have a hole.
You'd have a hole.
You wouldn't have to machine the holes. And that's what them are all for. You have a lot of them up around this end of them, which is this field.
But, see, that's girdage here. I like, but this is for the same, this is all one scale you've got here apparently. But this is your main lever. See, that's got a multiple of 6.
And this is what you got, Phil.
This is what I gave you.
Yeah.
Yep. Boy, so when they started trying to get a pattern going, we were in all kinds of trouble, because there wasn't anybody up there that knew what a pattern was like. But see, this has got double flange, and this one, you would split right through here. So you'd have, this would be the coat, this would be the drag.
Yeah.
Then you had to make cores to do all this inside was all done with cores. So it's just a reverse of what the mold is. But that core would be, would come up, that print would come up here like this, and clear down around like that, up in here like that. And you'd have to make that core, which would be this shape right here, and whatever else you put on for print. And after they've taken the mold out of the, take the pattern out of the mold, then you just simply set this core in there, and all you'd have would be just this. This would be core, and so all you'd be getting then would be just the outside of that thing, basically. And you'd have to put these pieces in the mold and that and that and this.
This is another, see this right here was a TU8. Anytime you see the number 8, you knew it was a main lever. They had a code.
Yeah.
6 was center levers and
12, I think, were
extension levers,
extension,
I believe,
yeah.
and were 5s.
I think so.
It's go back a long time, but
Multiple 6.
Multiple
it's a
6.
multiple 6. Yeah.
If you figure this is 5 feet from there to there, that's got to be, and this is a 10. So you see, you've got this is 60 inches, and that's 10. So 10 into 60 gives you multiple 6. So if you put 1 pound wheel, say here, you get the equivalent of 6 pounds over here, or whichever way to go. And that's basically what it is. And this is where you're basically your big I-beam, whatever they weighed on, it's going to sit on there, and then this is going to go on to this main lever. They go on to that part there. I don't know what I'm looking at there. It looks like now I know. Out of an old Printomatic.
Yep.
Now, when you fellows worked there, nobody ever came around and took pictures of the operation or?
Pictures hadn't invented cameras.
Right.
Oh yeah, there was a, although not of the actual operation of the molding and stuff, you didn't see it at all, the pattern they might have pictures of some of the castings or something, but
They did.
Yeah.
and there was a lot of them over there. Pelkey had them stored out back in a main room there. But I don't know if they throw them all away. I used to go out there often.
Now this is the old cast iron dial head,
Yeah.
and believe me, that was a work of art. Make one of them, wasn't it, Midge? This was this whole core was made out of green sand, just like Midge was molded with. And they had a cast iron arbor that went in here. It looked like a porcupine. We had little irons all around it. And they'd ram that thing up. They'd make, this would be the drag, I assume. Anyway, they'd ram that up. Then they'd take this thing that did all the inside parts. They'd set that down in here, and then they'd make this piece and set that over the top, and we've got one complete casting.
With the outside. And it was a funny thing, when we closed our foundry and we shipped some of our stuff out, I had a couple of foundries that actually wanted to get a hold of what they call green sand core. The guys in the foundry always liked it and never see it, heard it and never see it. I mean, we did things in this foundry. This foundry, just because it was St. John's, let me tell you, it wasn't a backwoods foundry. It was well thought of. Like I say, in '72 when we closed, the no-bake cores, and we were using it for molding too, we were way ahead of practically anybody in New England, and they used to truck in here. I mean, good foundries, big foundries came in. We had one little core room upstairs that we put together in just a couple of weeks. We had a lot of conveyor and everything in. An engineer named Al Ash got it, and we had one of the machines that, when it first came out, it was a 3-part binder for this no-bake. And it was so hard to adjust the machine and make decent cores, and we couldn't make it work. And we also didn't have a heater to heat the sand. The sand had to be hot. And when we used to buy the sand in the carload of sand, that would be so hot you could hardly stand in it when we got it. So it would work perfect when we dumped it. Of course, it was outdoors, on the cover, but outdoor bins, and it cooled pretty fast. So a day or two, we would get thrown pretty good with the hot sand, and then it would go cold. Well, finally, they came out with sand heaters that were relatively cheap. But in the meantime, we bought another machine, and also they changed the binder to a 1-part binder. or two-part binder, 2 pumps instead of 3, and which was easier. So we had one going in the regular coil room, but we couldn't keep up. GE was our big customer, and we set a little foundry up upstairs. And the good thing about that, you could make the cores. You could use them the same day, but it was better to make them today tomorrow. So they could get on the telephone and tell me they wanted 25 castings. Call me today, early in the morning, and I would make the cores, and the next day we would have the castings, and the following day they'd be on a truck going to Syracuse.
Wow.
They run our foundry. We were just like a captive foundry. I mean, they worked through us. We had certain machines that was theirs, and we tried to schedule the work as they gave it to us, and it just didn't work. So we said, how is this? You tell us what you want. You own machines, and we told them the capacity. That you can get 10 a day off on this, and 15 off on this, and 20 off on this one, and you tell us what you want, and give us 2 or 3 days to
So
do it.
you were working for GE?
Jobbing, yeah, over half hour work when we closed. It was jobbing. And GE was a company that nobody ever liked because they never gave you enough work, or they'd take it away from you. They had 2 or 3 patterns of everything. And they'd get in, and just you'd get going good, and then they would pull that deal. They'd go somewhere else, see if they could get them cheaper. But they always kept taking patterns away from you. But we got set up with them where we had so many patterns and did so much work in a turnaround that the tail wagged it out. We controlled our patterns, and we had no problem with taking work away from us. We've got along good with them on that.
We were talking about casting in pivots. This lever here, both that pivot and that pivot were cast in the mold. And those things had to be, like I said, they had to be perfectly level, the 2 of them. And they had to be right this way. Everything had to be square with relation to the center line. And that's where you had to add on a 32nd or a 16th, whatever, take out a range. I mean, it was.
And the hard part of that, these were tapered pivot and made in a blacksmith shop. No 2 pivots alike. So the fortunate thing for it, they only had to make a core print that's come from the outside of the cast into here. The inside was ironed from the mold, so they didn't have to make a print. They never could make a print that would fit pivots because they couldn't make pivots. It was like the prints, if you had to go the whole length, but the ends you could control. Yeah. And that's what they did on that. And the pivot was in that when they took it to the machine shop to grind it, or the grinding room, they knocked the pivots out, but they had to keep them in place because that pivot, even if it was identical to this one, it would not fit because they were made in the blacksmith shop.
Well, that's like that one I did for that old drop lever for down in Alabama, that old scale. It had cast iron pivots in it, and one of them was broken. I mean, the pivots were cast in, and one of the pivots were broken. Well, now, if you don't think that isn't fun to try to get one of them to fit, but the knife edge on this, which is that one there and this one here, those are supposed to be straight. So that's what you had to work from. And that's what